Question 7, Part C. Betty decides to set up a trust fund for her grandson, Lewis. She invests $80 at the beginning of each month. The money is invested at 6% per annum, compounded monthly. The trust fund matures at the end of the month of her final investment, 25 years after her first investment. This means that Betty makes 300 monthly investments. Part 1. After 25 years, what will be the value of the first $80 invested? Since we're trying to find the future value of a single lump sum investment of $80, we use the compound interest formula, A equals P times 1 plus R in brackets to the power of N, or future value equals present value times 1 plus R in brackets to the power of N. Both formulas are identical, it's just the terminology that's used. So the present value, or P, represents the principal or the lump sum investment. A, or FV, future value, represents the value in the future, of course. R is the compound interest rate per period, and N is the number of compounding periods. Now in this case, P, or present value, is 80. The interest rate per period, R, is 6% per annum divided by 12 because it's compounded monthly. And as a decimal, that's 0.005, and N is equal to 300, since there are 300 compounding periods over 25 years, and there are 12 compounding periods per year. So substituting those values into the compound interest formula, I'm going to use this one here. A equals 80 times 1 plus 0.005 in brackets to the power of 300, and that equals $357.1975 and so on, but we need to round this correct to the nearest cent. Therefore, the value of the first $80 invested will be $357.20 correct to the nearest cent after 25 years. Part 2. By writing a geometric series for the value of all Betty's investments, calculate the final value of Lewis Trust Fund. $80 is being invested at the start of every month over a period of 25 years. Now the first lot of $80 is going to be compounded for 300 months. And if you recall from part 1, the value of that $80 after 25 years is given by 80 times 1.005 to the power of 300. Now the second lot of $80 is going to be compounded for 1 month less. So it'll be compounded for 299 months. And the pattern continues in the same way until we get to the 300th installment of $80. And that's only going to be compounded for 1 month, and then the entire investment is going to be withdrawn alongside all the interest that's been earned. So the final value after 25 years is given by 80 times 1.005 to the power of 300 plus 80 times 1.005 to the power of 299 plus 80 times 1.005 to the power of 298 plus plus 80 times 1.005 to the power of 1. Factorising out 80 from all these terms, and there are 300 in total, that's why there's some missing here, obviously, I can't fit them on one row. That equals 80 times, open bracket, 1.005 plus 1.005 squared plus plus 1.005 to the power of 300, close bracket. Now inside the brackets here, we have a geometric progression or a geometric series with 300 terms. First term 1.005 and a common ratio of 1.005. So using the sum of a geometric progression formula, and we can represent this series here using that sum formula. We have 80 times 1.005 times, open bracket, 1 minus 1.005 to the power of 300, close bracket, all over 1 minus 1.005. And that evaluates to 55,716.71458 and so on. And we need to round this correct to 2 decimal places because it's a money value. Therefore, the final value of the investment after 25 years is $55,716.71.